Okay, so we have a forces question now. So we've got three blocks, I, or 1, right, 2, and 3, of masses 5m, 3m, and m, rest at a level horizontal surface and are joined in sequence by a string, as shown in diagram A. So they've got some strings here, and we expect that there will be some tensions. So some tension forces here. If I pull this block here to the right, it will pull the other one, which will pull the next one. A constant force F pulls the block of mass 5m to the right. There is no friction. What is the ratio of the tension in the strings joining blocks 1 and 2 to the tension of the in the string joining blocks 2 and 3? So if we observe this problem carefully, we should notice that all of the blocks, they are tied together. Therefore, if this is the force that's our resultant force, right? The force that's pulling those blocks forward. This should be some mass times some acceleration. I'll just use a different m here, so you understand that it's not the same as those lowercase m's. But what I mean here is all of those blocks, they will have to move with the same acceleration. So if this accelerates by, let's say, an acceleration a, this will also have an acceleration a, and this block will also have an acceleration a. So we can now observe each block individually. So let's take a look at this tiny block here, for instance. If we draw the free body diagram for that block, I would have weight, which is downwards, and I would have my normal force, which is upwards. Then I would only have my tension force, which is forwards. I'll call this T3, 2. Okay, it's hard to read. I'll write it like that. Okay, T3, 2. Now, if we do the sum of the forces, since it's not in equilibrium, it's accelerating, this should be equals to mass, which is lowercase m, times acceleration. But what is producing this acceleration? It's the tension, which is pulling it forward. So this is our tension. Right? The sum of the forces is the tension. Those two will cancel out. So the only force that we'll have is this one, and it's only horizontal. Now we can do the same thing for the second block. So if we draw the free body diagram for the second block, again, we will have some gravity. There will be some, however, they're going to cancel out because the block's not moving up or down. There will be some acceleration forward, some tension here. I'll call it 2, 1, and here I'll call it 2, 3. It's the opposite of that one. Same. It should have the same magnitude, but opposite directions. So if we do the sum of the forces, again, it's not equal to 0. It should be equal to mass times acceleration. For this block, the mass is 3m, so this should be 3ma. So what would be the sum of the forces? Well, if my acceleration is in that direction, it means that this tension is undoubtedly larger than this tension. So I could do T2, 1 minus T2, 3 equals 3 times lowercase m times a. Now, since this is the same magnitude of our T32, this is ma. Therefore, T2, 1 is equal, this was negative, so it's going to be 4ma. So the question is asking us, what is the ratio of the tension in strings joining block 1, 2, and 2 and 3? So we would have to do T1, 2 over T2, 3. So T1, 2 is 4ma. In this case I've done T2, 1, but it's just the same value, same magnitude, just opposite directions. And T2, 3 was ma. Therefore the ratio is 4.